Hello everyone, I am Chahat Tandon from BIET College Davangere and I am here to tell you a little bit about machine learning. There is no limit to what machines can do today. It's very hard to find a field that is not benefited by machine learning, and if there is one, it makes much more interesting. Machines play games, hire people, trade cryptocurrency, drive cars, help in diagnosing diseases, suggest applications for your phones and laptops, shows you ads on Facebook, helps you arrive at your destination by car, and much, much more. By being in machine learning field, you can work almost in any other field. Let's start by learning some Python basics. You have to install Anaconda. Let's see what all are the major types of data. Numerical data is the data that is measurable, such as time, height, weight, amount, and so on. You can help yourself identify numerical data by seeing if you can average or order the number given in the data in ascending or descending order. Ordinal data has a mathematical meaning. It is the kind of categorical data with a set of order or scale to it. For example, ordinal data is said to have been collected when a responder inputs his or her financial happiness level on a scale of 1 to 10. There is no standard scale on which difference is measured. Let's see what categorical data is. It's basically qualitative data with examples like age group, race, educational level, etc. Basic terms. The mean of a set of data values is the number of all the data values divided by the number of data values. The median is the middle number in a sorted ascending or descending order list of numbers and can be more descriptive with the set that ranges the average from. To find the mode, it is best to put the numbers in order. Then count how many of each number there exists. A number that appears most often is called the mode. Variance is the expectation of the squared deviation of a random variable from its mean. Informally, it measures how far a set of numbers are spread out from their average values. Standard deviation is the square root of variance. Probability mass function. It is the probability of a given discrete value. A function that represents a continuous probability distribution is called a probability distribution function. Population versus sample. A population is a data spread out in a space, and a sample space is just a part of the data taken. Percentile in a data set, what the point at which X% of the values are less than that value. Example, income distribution. Moments. Quantitative measures of the shape of a probability distribution function. Covariance. It measures how two variables vary in terms of their means. Conditional probability is the probability of B given in accordance to A. Correlation is how one or more variables are related to each other. This is the Bayes theorem formula. Probability of A occurring given evidence B has already occurred is given by probability of B given A has already occurred into probability of A occurring divided by probability of B. Let's have a look at what predictive models are. Linear regression. Linear regression is a linear model, for example, a model that assumes a linear relationship between input variable X and single output variable Y. The biggest advantage of linear regression model is linearity. It makes the estimation produce simple, and most importantly, these linear equations have an easy understanding and interpretation. There are 3 stages to it. Analyze the correlation, estimate the model by fitting the line, and evaluating the validity and usefulness of the model. Here's an exercise which you can try and you can check your answers. Polynomial regression. The goal of polynomial regression is to model a non-linear relationship between independent and dependent variables. Polynomial regressions have 5 stages. First is data pre-processing. Build a linear regression model and fit it to the dataset. Build a polynomial regression model and fit it to the dataset. visualize the results for both. Polynomial provides the best approximation of the relationship between dependent and independent variables. Polynomial basically fits a wide range of curvature. Let's have a look at machine learning with Python. There are two types of learning, supervised learning and unsupervised learning. Supervised learning takes input data, which is labeled. Unsupervised has unlabeled input data set. It is used for training data set, whereas unsupervised is used for analyzing. Predictions are made based on supervised learning, and it includes classification or categorization, whereas clustering, destiny estimation, reduction, etc. comes under unsupervised learning. K-means clustering. K-means clustering algorithm computes the centroids and iterates until we find its optimal centroid. It is used to flat cluster the given data. The number of clusters identified from data is represented by K in the K-means. This is an example of poor clustering, as all the data is not clustered properly and can be very confusing. And this is an ideal clustering. Entropy and decision tree. Entropy is basically the measurement of randomness in an information given to us. Whereas decision tree is a creative model that predicts the value of a target variable by simple decisions. It can be a yes or no, or a negative or positive value, or whatever you want it to be. Now, what are recommender systems? Recommender systems helps the user select similar items when something is being chosen online. Companies like Netflix or Amazon would suggest users different movies that would interest them and are worth watching. Collaborative filtering and content-based filtering. Collaborative filtering is a method of making automatic predictions, that is, filtering about the interests of user by collecting preferences or information from many users, that is, by collaborating the information. The underlying assumptions of the collaborative filtering approach is that if a person A has the same opinion as person B on an issue, A is more likely to have B's opinion on a different issue than that of a randomly chosen person. Whereas content-based filtering uses item features to recommend other items similar to what user likes based on their previous actions or explicit feedbacks. Now we can say that content-based filtering outperforms user collaborative filtering. Items are more similar and make more sense than the user similarities, right? Now let's see a machine learning project demo, shall we? We have the live data set of COVID-19 affected people till 18th of June. We have the states, confirmed cases, recovered cases, deaths, active cases, and the last updated time. We plot a graph of total cases versus the percentage increase till the 18th of June. We can also plot the recovered cases state-wise. So we can see that the most recovered cases are in Maharashtra, whereas the least is in Sikkim. But also the level of cruciality and how much cases there actually were is also different for different states. At last, we are plotting a graph which is basically percentage increase over dates. As we can see, even if the number of cases is increasing day by day, the percentage increase is actually decreasing gradually or exponentially, but increasing linearly. As the total cases, that is percent I decreases, it can be said that it is currently increasingly linear and not exponentially like we expected it before. So we can say that India has succeeded in keeping the cases of COVID-19 stable so far. Thank you.
Hello everyone, I'm Sanjana. Here let's learn more about data mining and machine learning techniques. First technique is KNN. KNN stands for k nearest neighbors. It is a non-parametric method for classification and regression. It uses the data which is already present to classify new data based on a similarity measures. Let's consider an example. Here there are two classes A and B and an unknown class in green color. If we take k value as 3, we get 2 points of class B and 1 point of class A. These points are data points and k is the count of nearest neighbor. Uh, Here k is 3 and 2 points of we get 2 points of class B and 1 point of class A. That means that unknown data point might belong to class B, and if we extend the k value to 6, we get more number of points of the class A, and so we can predict that the unknown point might belong to class A. We have to keep this k value small as possible. Let's see dimensionality reduction. It is basically reducing the high dimensional space to low dimension, and it is also known as it is called the curse of dimensionality. Suppose a flower has 4 properties and each property is taken as 1 dimension, and 4 property will become 4 dimension, and it is not easy to classify it. So we have to go with the dimensionality reduction technique. It is not only used for visualization of data but also for compression and feature extraction. PCA, Principal Component Analysis. PCA is one of the dimensionality reduction technique. It emphasizes variation and bring out the strong patterns in the dataset. It takes the dataset and finds out its um, planes called as hyperplane defined by eigenvectors. Consider a iris flower dataset. It is represented in 4D space, and PCA can represent the same to 2D, preserving its variation. The use case. Business objective is to categorize the input by using KNN and visualize the dataset. Business objective is we get the respective visualization of the iris dataset using the PCA like this. This is the code. First, we have to import the libraries and read the dataset by using the following URL here. Then the Euclidean and the KNN predict functions are used to calculate the distance. Then random values are provided to test and accuracy is calculated. We get accuracy as 94%. The graph of sepal length and width is plotted here, and the similar points are grouped together using PCA. Data warehousing. It is a giant database which contains the data from many sources, and its challenge is to take the data and transforming it into many different schema to query, and the data normalization and its maintenance and also scaling. Is the extract transform load and extract load transform, that is ETL and ELT are the flows to load the data. Here ETL is the traditional flow, and when we are dealing with the big data we have to go to ELT. In ETL we have to first extract the data, then transform and then load into the data warehouse, while in the ELT we have to transform, first we have to extract the data and then load, and after that with the help of some software and tools like Hadoop, we can easily transform the data easily and quickly. Let's look at biasing and variance. But in the basic challenge we face while dealing with the real world data is overfitting and underfitting of the data in your model or the regression. Bias and variance are bias and variance can be applied here. Bias is nothing but how far is your predicted values from the real, and variance is how scattered or spread is your predicted values from the real one. At the end of the day, you have to reduce the error, neither bias or not the variance. These are the types of bias and variance: low bias, high variance, high bias, high variance, high bias, low variance, and low bias, low variance. And the error is calculated by bias square plus variance. Let's look how to avoid overfitting using k-fold cross validation. It is a robust process where the data is segmented into k segments, and one segment is reserved for test data, and k minus 1 segments are trained measuring their performance. The same is repeated until all the k segments are trained, then the average is taken to calculate its performance. Next, look at handling unbalanced data. Handling unbalanced data. What is unbalanced data? It is a large discrepancy between positive and negative cases, like fraud detection. In fraud is rare, and most rows are not even fraud. For example, if your machine learning model is made to detect fraud, then the fraud becomes your positive case. The solution for this is oversampling. It is nothing but duplicate the samples from the minority class, and it can be done at random. Next is undersampling. Instead of creating more positive samples, we have to just remove the negative ones. Next is synthetic minority oversampling technique. It is a artificially generated we have to artificially generate new samples of minority class using the nearest neighbor. It is much better than oversampling and undersampling. Next, features for engineering. Feature engineering is nothing but own apply your knowledge of the data and the model you are using to create better features to train your model with which the features like which feature we have to use. Do I need to transform this feature into same or y, or how to handle missing data. The techniques here are transforming, encoding, uh, scaling or normalization, and shuffling. Introduction to MLlib. MLlib is the Spark machine learning library. Its goal is to make practical machine learning scalable and easy. At the high level, it provides some tools like ML algorithms for that like classification, regression, clustering, and collaborative filters. These are some of the capabilities of MLlib. It is feature extraction, basic um, statistics, linear logistic regression, support vector machines, decision trees. K means clustering, BCA, SVD, and recommendation using alternating least squares. A/B testing. A/B testing is nothing but the testing done basically on the websites. This controlled experiment to use in context with website. The test the performance of some change to website and measure conversion relative to changes and site. Some sort we can test like design change, algorithmic change, UI flow, etc. This is the test case on A/B testing. Uh, Objective is to analyze two different website implementation and statistical significance of newer design on website traffic metrics using A/B testing. Outcome is we get high p-value. It implies that null hypothesis we assumed cannot be rejected as the result is not statistically significant. This is the code here. First, we have to import the libraries and load the home page dataset. convert the date time and set null and alternative hypothesis for this. Then simulate distribution under null hypothesis and plotting the null hypothesis distribution also. Then compute the p-value. We get the high p-value, so the null hypothesis is accepted at the last. Thank you. Happy learning.